Okay, class. Recently we've discussed the scientific method and we've kind of come up with definitions and parts of it. But to really understand the material, let's just have a more broad discussion where we kind of dissect the components and look at what could be some faults in the scientific method and even read an example of the scientific method actually in practice and see if you think they actually follow the method or if it was more of a case study situation. So the first thing that we're going to do is kind of just talk about what do you think the purpose of the scientific method is overall? What do you guys think the purpose is? Like, why even go through the scientific method?
Well, it gives you sort of a standard for all science classes. It's really standardized. It gives you like a method to follow when you're doing an experiment, so you know like which steps to do in which order.
What do you think?
It's kind of in the same thing. It's just like a set standard that everyone follows. And so if I do an experiment and you do the experiment, we should come out with the same solution like if we follow those steps.
Exactly. And you're alluding to a term that we've covered before. What is that when I do the experiment and you do the same experiment? What term is that she just kind of described and we get the same results? Exactly. It's reliability. Because that's also one of the important facts of the scientific method. That's one reason why we try to do it in that way. And we've also discussed in class like another reason for doing the scientific method. And one of those reasons is because of data. Like before the scientific method, people just didn't use the collection of data. So does everybody understand what is the difference between reliability and validity? We kind of discussed this. Does anybody understand the difference?
Well, you can't have validity without reliability, is that correct? And so reliability is just showing that like, if I do this experiment and you do it, that we have the same results. And validity is more or less the like whether what you use to supplement your data is valid. Like if it's like coming from good sources.
Like if you're testing what you're supposed to be testing.
Yeah.
Exactly. You guys are on the ball. What's the difference between quantitative data and qualitative data?
Quantitative data is like, it has to do with numbers. Is it like the amount of data that you have? Is that it?
It's numbers. It's basically the description of your data. Are you describing your data with numbers or with words?
Okay. So qualitative, would that be words? Okay.
That would be more like characteristics and stuff. Exactly. Who can differentiate between dependent and independent variables?
This is always confusing.
Okay. We're going to break it apart to make it really easy to understand. From our notes, we see that dependent variable are ones that depends on the independent variable. So, in layman's terms, it's the result of what you're doing. And the independent variable is something that you just do not manipulate. It's actually it's what causes the change. So does that make sense?
So it's like the situation, and then like the dependent variable is like the outcome of the situation, kind of. Like if you were going to put it in those terms. Okay.
Okay. What's the point of having a hypothesis, and how do you go about formulating a hypothesis?
Isn't a hypothesis sort of like a question that you want to have answered whenever you're doing your experiment?
Right.
It's like the initial question.
So would I just decide one day, I want to hypothesize that paper is going to turn gold just by making up this, or would I actually have to observe some stuff beforehand and then make the hypothesis? Or would I do research before I make my hypothesis? Or would it just be like, I just think this is going to happen, so I'm just going to create an experiment to see if this happens?
Probably run just some experiments.
Right.
Or at least some observations.
Observations are very important with hypothesis. That's normally how you initiate a hypothesis. You observe some stuff, or you look at some old experiments, you're like, I wonder if this will happen too. So these are just some of the big points that we've talked about with the scientific method. If you can, try to read through this little small print and read about this article. As you read, I'm going to tell you a brief summary of what this article is. It's basically saying that people who attend religious services have a tendency to be obese. And so they try to make a connection between obesity and people who attend religious services. And I just want you guys to read through it. You don't have to read all of it. Just to get some summary of it, because we're going to kind of dissect the article a little bit and see what could have been some flaws in this method. Is this actually an experiment? Is it showing causation or is it showing correlation? And how does that actually impact like society? How is it, should we say we shouldn't go to church anymore because we're gonna all become obese or what? Everyone have a little gist of what's going on? Okay, so what do you think? Do you think that this is an experiment? Do you think they actually conducted an experiment when they took people out of their homes and, you know, asked them to attend religious services and watched them gain weight? Or do you think it was more so they went to religious services and said, okay, on average here it seems that people are more overweight? What do you think happened?
I think it's a
Survey, exactly. That's exactly right. So how valid is that? How should this impact our lifestyle? Should we say we don't want to go to religious services anymore? Because if they only surveyed people who went to religious services, how should that impact our lifestyle? What do you think?
Well, I feel like they can say that, yes, people at churches may be more obese, but that doesn't mean that churches are like
obesity.
Yeah, there's like some sort of intervening, like something else is like causing that. Whether it's like, I know they mentioned like meals, like having, or like traditional, holiday foods and stuff.
Like around Thanksgiving or something, or you know, like.
Or I mean, it could be a multitude of things, like your like hereditary,
exactly.
Or anything, like I don't know, it could just be a lot of different things.
So you think there were biases?
Yeah, I don't think it was thorough enough to really give any valid information.
Do you think they followed the scientific method? Or do you think it was more, if it was a survey, is that the scientific method? Because did they manipulate a variable?
No. I mean,
and did we
I feel like they kind of did because they accounted for race.
I saw that.
And so that's somewhat.
You're gonna.
In the essence of time, I think our class is over. So just to summarize what we went over, we often see this in the news. We often see where they correlate, and news people will kind of say, well, this must be causing this, or that must be causing this. But we just have to be careful and ask ourselves, if they follow the scientific method, if they did, how should this impact our lives? And I'm glad that you said what you said, like, yeah, they kind of did. So yes, just because you follow the scientific method, that doesn't mean that you won't have flaws. Because like you implied, there can be biases in your results based off of genetics and hereditary and stuff like that. So I'm just hoping that all of this is very informational.